Okay, so in this last and final video, we're going to go ahead and tune the motor current settings so that we can drive these motors correctly. Now, the motor current settings on your printer may vary depending on the type of motor controller that you have. This uses the Allegro 4988 motor controllers, and each one of them has their own specific settings, which we'll have documented on our website once we figure out all of the different variations that you guys have out there. But in general, the 4988 can drive the motors that we have, and pretty much every other driver out there that we are aware of can do it. Some of them actually use a software tuning. So for example, if your machine uses what are known as digipots or digital potentiometers, that's actually used a setting. They use a setting in the software to tell it how much motor current should be applied to this. Now, the Creality motors that came with this machine are actually a very low impedance motor, so it's roughly in the 2 ohm range. The motors that we use are called induction motors. They're a little bit higher. In fact, they have 34 ohms of resistance in them. And the reason why we use them is that we can actually pair these up into have multiple ones, and we still fall within the available current ranges of most of the motor controllers. So there was a technical reason why we chose this particular motor. It allows for a more flexible installation, but it does require motor current adjustments. In the future, we're actually going to be offering specific motors for specific printers, but at this point, we're not at that point just yet. So in order to adjust the motor current, we need to open up the electronics panel of the Ender printer here. And I'm just going to go ahead and grab my 2mm wrench. There are 2 screws on the front side here, and there's 1 screw on the back side. I'm going to go ahead and remove it first. Now you don't want to lose those. This is the one on the back is the longest screw. The 2 on the front are actually shorter. They actually go right into the metal. The one in the back actually has a pretty big gap between the metal plate and the actual screw mounting point. Okay, with those 3 screws removed, this panel will just pop over out of the way. Now, you want to be careful, it's still attached with a fan wire. And the motor current adjustment potentiometer is a little tiny plus sign screw right in front of the frontmost heatsink here. And I'll show you a close-up view of it here. Okay. And what we're going to do is we're going to take, I'm going to show you the cheating way of doing it. We are going to move our printer over so that we can get to it. We are going to apply power to it, so you want to be careful. It is open now. We're going to go ahead and turn it on. We're going to use our voltmeter, and we're going to set it to 2000 M on the volt scale, which is 2000 millivolts. In other words, this can measure up to 2 volts. We're going to go ahead and turn it on, and you should get some random data on the screen there. And to properly measure this, what we're going to do is we're going to use the black wire, and we're going to connect to the case of the SD card reader. That's a ground point. And the red one we're actually going to put right in the middle of that little plus sign potentiometer adjustment. The way you properly adjust this is you measure the voltage between the middle of the potentiometer and the ground point. And the default factory settings are, in this case, around, well, they vary. This particular one is 564 millivolts. I've seen them as high as 700 millivolts. In fact, I believe on the other motors they are at that point. That one is. Yeah. So these stepper motor controller currents are much higher than what we're going to be running. We need to dial that way back. So in this case, it has a millivolt setting of 558. We're going to take our custom-made screwdriver. Now, how did I make this screwdriver? If you look at that, there is a plus sign right in the middle of it, and that's actually designed for a small plastic Phillips screwdriver. but it will also work with the straight head Phillips screw or straight head screwdriver. So what I'm going to do is I'm just going to take a piece of the filament and I'm going to cut it off at a very aggressive angle so that it goes up to a nice flat point on one side. So I'm then going to turn it 180 degrees around and I'm going to do the exact same thing. So I get a flat V-tip in the middle. That V-tip is now our screwdriver. I can then use that to dial this current back. Now we're going to turn it counterclockwise or anti-clockwise, depending on which country you're in. We're going to turn that counterclockwise, dialing the motor current down. We want to get to a motor current of 256. That's the ideal motor current for these stepper motors with this controller combination. Like I said, each motor has its own phase resistance, and we need to adjust the current to match that resistance to get the proper voltages applied to it. In our case, that voltage for these motor controllers should be at 256 millivolts. So I'm just going to put that right down inside there and I'm going to dial it back. As I turn it back, we'll then go ahead and measure it again. Now, these are very touchy. You don't have to move it very far to get a big swing in the current. A little farther. So in this case, my value is 267, 265. So it's bouncing around that 265 mark. That's good enough. 256 is a range, plus or minus 20 or so. So we're well within that range. So we have a current setting just about right where we want it. It's going to be very hard to get it exactly 256. Don't try. Like I just did, 265 works perfectly. We're good with that. So now that the motor current is set, I'm going to turn that off. We can go ahead and turn the power back off and close this back up, and we're ready to go. So let me go ahead and do that. So we'll place that back in its location. Turn it around correctly so it fits in the right location. There you go. Again, we're going to use the shorter screws in the front, longer screws in the back, longer single screw is in the back. Now I'm going to install these, but I'm not going to tighten them just yet. Because this last one is the tricky one. So it's got to go down into a hole that is several millimeters below the actual opening. Got it right on the first try. Good. All right. So now that that's done, the only step left to do is to use your zip ties to clean up the wires. I like to actually have them nice and zip tied out of the way so they don't move. I like to sit these under wires underneath the side extruder here. It kind of holds them in place. And by the way, now that I have this cable in the right place, I can actually reach in there and tighten this extruder back down. So that'll take care of that. So we have a nice bundling of wires. And you might even have a couple loose of the larger zip ties. Just use those to make loops to hold these tubes back. That way when it moves around, it actually doesn't fly forward. What you don't want this to do is to fly forward and bend forward. You just want to hold them back, just kind of like that. And that's it. The installation is done. In the next video, we're going to go ahead and take a look at how to slice software, how to slice models using the various different bits of software to actually run a multicolor print on the 3D Chameleon.